Unexpectedly, galactic events of extraordinary scale happen billions of kilometers from Earth, resonating throughout the universe. As of now, a similar event is approaching, causing shock even among scientists. A red giant star located at the outer reaches of our system is emitting ominous signals across the universe, detected by the James Webb Space Telescope. Astronomers have uncovered deeply unsettling revelations about this legendary celestial body. As renowned astrophysicist Brian Cox issues a grave warning, a pressing question arises. Are we on the verge of witnessing a catastrophic stellar explosion that could forever change the night sky? Before diving into further details, make sure to subscribe to our channel if you haven't already. Now, the burning question remains. Will this impact Earth, and will it be visible from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the vast expanse of the universe, where the cycle of stellar birth, life, and death unfolds in mesmerizing wonder, one particular star has recently captured the attention and concern of both astronomers and the general public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the Orion constellation, boasting an immense size and age. While its striking reddish hue and fluctuating brightness have long fascinated observers, recent events have further heightened interest in this colossal behemoth. As we delve into the nature of Betelgeuse, we find ourselves standing at the very edge of a potentially monumental event in the star's life cycle. But what do these changes in Betelgeuse's behavior mean? Could we be witnessing the precursor to a spectacular and massive explosion? Betelgeuse, with a size over 700 times greater than our Sun, remains a true giant among stars. Its sheer magnitude stretches the limits of human imagination. Imagine a star so enormous that, if it were to take the Sun's place, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars within its colossal grasp. This incredible scale not only highlights Betelgeuse's status as a true giant, but also signals its position in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise regarding Betelgeuse's age. While relatively young in human terms, estimated to be around 8.8 to 8.5 million years old, it is quite ancient in the context of stellar lifespans. Its current status as a red supergiant represents the final stages of millions of years of stellar evolution, characterized by dramatic transformations from a hot blue star to the massive red giant we see today. The evolution of stars like Betelgeuse unfolds as a story of constant change, driven by the relentless forces of nuclear fusion and gravity. One prominent feature of Betelgeuse's current phase is its deep red tint. This dim red coloration arises from its relatively cooler surface temperature compared to stars like our Sun. While our Sun shines at approximately 5,500 Kelvin, Betelgeuse's surface is much cooler, averaging around 3,500 Kelvin. This lower temperature allows Betelgeuse to emit light in shades of red. However, this color is not just a visual characteristic. It provides crucial insights into the star's physical state and the ongoing processes within its massive gaseous envelope. Adding to the intrigue surrounding Betelgeuse is its mysterious color history. Ancient records from Roman and Chinese sources suggest that nearly 2,000 years ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic scholars described it as red. This historical change in color is not just a footnote in astronomical records. It serves as a clue to the star's ongoing transformation. Betelgeuse's fluctuating brightness adds another layer of fascination. It is classified as a semi-regular variable star, meaning its luminosity undergoes periodic variations. This rhythmic brightening and dimming have captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 400-day cycle, alongside a longer 5-year cycle, first noted in 1836 by Sir John Herschel, and possibly even earlier in indigenous oral traditions. However, what truly sets Betelgeuse apart is its unpredictable behavior. Unlike many stars that follow consistent patterns, Betelgeuse sometimes deviates from its usual dimming and brightening cycles. This anomaly suggests complex and less understood processes occurring within its immense structure. Recent astronomical discoveries have astonished astronomers and space enthusiasts worldwide. In late 2019, Betelgeuse experienced an unprecedented and dramatic event, now widely referred to as the Great Dimming. The phenomenon began when the red supergiant, a bright and iconic feature of the Orion constellation, suddenly started to lose its luminosity at an unusual rate, dimming by an average of 0.01 magnitudes per day. By February 2020, Betelgeuse had reached its lowest recorded brightness. Normally visible to the naked eye, even in light-polluted areas, Betelgeuse had dimmed so significantly that even amateur observers noticed the change. Scientists scrambled to understand what had caused this abrupt shift. However, studying Betelgeuse presents a fundamental challenge: the time delay problem. When we observe a star like Betelgeuse, we are not seeing its present state but rather its past. Due to the time it takes for light to travel, what we see today actually happened approximately 725 years ago, the time it took for Betelgeuse's light to reach Earth. This delay complicates efforts to predict and track sudden changes in a star's behavior, as we are essentially witnessing events that occurred in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent complexities in cosmic observations and the limitations of our understanding when grappling with the vast scales of time and space. The fascinating journey of Betelgeuse's celestial drama has been meticulously studied by Andrea Dupree, a leading astronomer. Colleague, head of the Middle for Astronomy at Harvard and Smithsonian, alongside her group, utilized the Hubble Space Telescope. They embarked on a 3-year study to monitor changes in Betelgeuse's outer environment. These observations provided a rare understanding of how a variable star like Betelgeuse behaves, with its natural expansions and contractions leading to fluctuations in brightness. The striking sensitivity of Hubble to ultraviolet light enabled the scientists to examine the layers above Betelgeuse's surface, which were partially heated by the star's turbulent convection cells. Moreover, a detailed analysis of the Hubble spectra, collected at various intervals throughout 2019 and 2020, facilitated the measurement of material movement within Betelgeuse's outer atmosphere. Specifically, the study focused on the magnesium-2 lines in the spectra, which offer insights into the star's atmospheric conditions. These observations revealed material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its outer atmosphere. This heated and dense material eventually expanded thousands of miles from the star, forming the precursor to the dust cloud responsible for its dimming. Dupree and her team estimated that during the 3-month event, nearly twice the usual amount of material was ejected from Betelgeuse's southern hemisphere. This significant mass loss is particularly remarkable because, like all stars, Betelgeuse continuously sheds mass, but at a much higher rate than our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could indicate an impending supernova explosion. The proximity of Betelgeuse, located approximately 725 light-years from Earth, adds to the intrigue. If such an explosion were to occur, it would be visible from Earth, presenting a fascinating opportunity to closely observe a supernova. But the question remains: what does this dimming event mean for Betelgeuse's future? Does it signal an impending supernova, or is it merely a temporary phase in the star's vast and complex journey? Different theories have been proposed to explain this phenomenon. One hypothesis suggests that it is a stage in the supernova process, gaining traction due to the widespread belief that Betelgeuse is nearing the end of its life cycle. Another widely accepted theory implicates dust, possibly originating from the star itself, obstructing our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its visible surface layer, which could affect its apparent brightness. Comprehensive analysis using diverse observational techniques contributed to unraveling this mystery. Spectroscopic evaluations indicated a decrease in Betelgeuse's effective temperature, suggesting the presence of a significant dark spot on the star's surface. This hypothesis was supported by observations revealing a temperature drop of at least 170 Kelvin during the dimming period, highlighting substantial surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humanity's careful gaze into space via the Hubble Space Telescope. Hubble's precise observations revealed that Betelgeuse's dimming was likely caused by a massive ejection of heated material into space. This material coalesced to form a dust cloud, blocking part of the star's surface and reducing the amount of light reaching Earth. The formation of the dust cloud was attributed to superheated plasma, which erupted from a large convection cell on the star's surface and traveled through its scorching atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that obscured light from approximately 1/4 of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of dense, heated material moving through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's decreasing brightness, particularly in its southern hemisphere. Initially, this material appeared brighter than the star's usual radiance, ultimately culminating in the formation of a shadow as it dispersed outward and cooled. The concept was straightforward. This outward flow of material and the resulting shadow were responsible for the star's sudden dimming. The scale of this ejection is truly astonishing, pushing Betelgeuse into the cosmic spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be substantial enough to offset our moon several times over, marking a significant event not only for Betelgeuse but also for advancing our understanding of stellar mechanics. But what are the implications of such a massive release of material for Betelgeuse and broader supernova theories? The conventional wisdom suggests that red supergiants like Betelgeuse typically shed mass before reaching the explosive peak of their existence. However, the magnitude of this ejection challenges this idea, hinting at a potentially more volatile and unpredictable final stage for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion within the next few centuries? Later research speculated on the timing of such an event, suggesting it may happen sooner than previously expected, perhaps within just a few years. Furthermore, the nature of Betelgeuse's bow shock adds another crucial layer to the mystery. As this massive star races through space at approximately 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, similar to the wake formed by a moving ship's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a spectacular display of Betelgeuse's dynamic behavior and its interaction with the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and reduced brightness, observed following the ejection event, have left the star in a disturbed state even years later. Hydrodynamic simulations suggest a connection between the star's convective activities, the mass ejection, and subsequent changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Moreover, Betelgeuse's observed mass loss rate exceeds that of many other stars, reflecting a complex interplay of internal forces. With energy constantly dissipating through shock heating and mass ejection, Betelgeuse's rhythm is shifting. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to reconsider their models of stellar evolution.